Greetings, fellow muckers. Today, we'll be working on a risk aversion problem. Risk aversion is the tendency of people to prefer outcomes with low uncertainty to those outcomes with high uncertainty. The problem. Suppose the individual has utility function u of x is equal to the natural log of x over monetary outcomes. Part A. Is this individual risk averse? Part B. Is this individual more risk averse than an individual with the utility function u of x is equal to x to the 1/2? Now pause this video, take a few minutes, and solve this problem. Welcome back. Hopefully you were able to solve this problem. Now let's work on it together. Part A. Is this individual risk averse? So we need to determine if the utility function u of x equal to the natural log of x is risk averse. So how do we do that? Well, we need to find the natural log of x second derivative, and we need to determine if it is less than 0 or strictly concave. If it's concave, it inhibits or it shows or exists risk aversion, because risk aversion is having a concave shape over x. So let's solve this. So we have u of x is equal to the natural log of x. The derivative of natural log of x is equal to 1 over x. The second derivative of 1 over x is negative 1 over x squared. Now, is negative 1 over x squared less than 0 for all x? Yes, it is. So negative 1 over x squared is less than 0 for all of x. Doesn't matter what we plug in for x1, negative 2, negative 3, negative 100, still negative. So it exists a strictly concave relationship. So therefore, u of x is strictly concave. Therefore, exhibits risk aversion. Now, that is the answer to part A. So, is this individual risk averse? Yes. Part B. Is this individual more risk averse than an individual with the utility function u of x is equal to x to the 1/2? Well, to do this, we need to find both utilities' risk aversion ratios. So how do we calculate those? Well, so this is the risk aversion of x for utility of x is equal to natural log of x. And the relationship to find this is you take negative u of double prime of x, and then we divide it by u prime of x. And this is equal to the risk aversion ratio. So, for natural log of x, the second derivative is negative 1 over x squared divided by 1 over x. There's a negative in front. So this becomes positive. So this becomes 1 over x. When you simplify it, because 2 minus 1 is 1. So 1 over x. And this is equal to RA of x. Now we need to find the ratio for RA of x for utility of x is equal to x to the 1/2. Same thing, RA of x still going to be equal to negative u double prime of x over u prime of x. So u prime of x in this case is going to be equal to 1/2 x to the negative 1/2, and u double prime of x is going to be equal to negative 1/4 x to the negative 3/2. So now we need to find this ratio. So we take negative 1 over 4x to the 3/2 divided by 1 over 2x to the 1/2 is, and if we simplify this, we're going to get 1 over 2x as this ratio, 1 over 2x. And so this is equal to RA of x. Now, we found both ratios. Now, if we have positive x values, so for x greater than 0, which one of these ratios is bigger than the other one? Well, if we plug in 1 is bigger than 1/2. We plug in 2, 1/2 is bigger than 1/4. So we can see as x, when x is positive, u of x is equal to the natural log of x is greater than u of x is equal to x to the 1/2. Therefore, the individual with utility of x equal to ln of x is more risk averse. And that is the solution to the problem. However, just a quick statement, if x is negative, it would be the other way around. The individual with the utility of x to the 1/2 will show more risk averse than the individual with the utility of natural log of x. But that is the solution to the problem. I hope this video helped. If it did, please consider subscribing and liking this video. Thank you.